Welcome to our Calculus 1 videos. This video is going to discuss limits at infinity. And first I'm just going to explain sort of the concept of what is a limit at infinity. And we're going to look at this function e to the x. So when we think about the limit as x approaches infinity of e to the x, we notice that as we go towards the right on the x-axis, so as x goes all the way this way towards infinitely large values, e to the x grows upward without bound. So this means the limit as x approaches infinity of e to the x is infinity. Now, the limit as x approaches negative infinity of e to the x, well, what's that going to be? So, we're going to look as x gets really, really large in the negative direction. So as x gets really, really large in the negative direction, as in if we plug in very, very large values, large negative values into e to the x, we get numbers that get closer and closer and closer to 0. So that tells us the limit as x approaches negative infinity of e to the x is 0. And basically what a limit at infinity is going to tell you is there's going to be a horizontal asymptote, and that's going to be at this limit value. So e to the x has a horizontal asymptote at x equals 0, because as x gets larger and larger in the negative direction, this function e to the x gets closer and closer to the line x equals 0, which is the x-axis. So we would not have a horizontal asymptote on the other side, because as x approaches infinity, well, e to the x grows without bound. So there's only one horizontal asymptote for e to the x. And this also means a function can have at most two horizontal asymptotes. One when we take the limit as x approaches infinity, and one when we take the limit as x approaches negative infinity. So that's the concept of a limit at infinity. Now we're going to take a look at two examples. So here's our first example, and we're going to consider the limit as x approaches infinity of this quotient. And the first thing we want to notice is if we try and plug in really, really large values of x, what happens? Well, the numerator, we've got this x cubed, and then this whole quantity is being squared, and so that's going to get really, really large as x gets really, really large in the positive direction. And in fact, it's going to get closer and closer to infinity. As we plug in super, super large values of x, large positive values of x, this numerator is going to trend towards infinity. Now the same thing actually is going to happen on our denominator, because we have this x squared and multiplied by something else, that's x to the fourth is going to get really large, so this is also going to trend towards positive infinity. So now we have this sort of type infinity over infinity. Now keep in mind, we're not plugging in infinity itself, we're just saying what happens as x gets really, really large. Well, this quotient is going to look something like infinity, an infinitely large number over an infinitely large number. And we actually don't know what that is. We don't know if that's going to cancel and be 1, or a positive value, a negative value. It could be infinity. So we're going to have to rewrite this quotient a little bit better so we can understand what's going on. So a good strategy for that is we're going to consider the highest power of x in the denominator. So in this case, that's going to be, we have an x squared times an x to the fourth here. So that's going to be x to the sixth. So we're going to multiply by 1 over x to the sixth over 1 over x to the sixth. And what that's going to do for us is it's going to allow us to write this quotient in a way that we can understand better what's going on. So this is going to become 6x cubed over x cubed, because we're going to pull this x to the sixth inside of this square. And so 6x cubed over x cubed, because we're going to pull this x to the sixth inside of this square. And so 6x cubed over x cubed, because we're going to pull this x to the sixth inside of this square. And so 6x cubed over x cubed, because we're going to pull this x to the sixth inside of this square. And so 6x cubed over x cubed, because we're going to pull this x to the sixth inside of this square. And so 6x cubed over x cubed, because we're going to pull this x to the sixth inside of this square. And so 6x cubed over x cubed, because we're going to pull this x to the sixth inside of this square. And so 6x cubed over x cubed, because we're going to pull this x to the sixth inside of this square. And so 6x cubed over x cubed, because we're going to pull this x to the sixth inside of this square. And so 6x cubed over x cubed, because we're going to pull this x to the sixth inside of this square. And so 6x cubed over x cubed, because we're going to pull this x to the sixth inside of this square. And so x cubed squared is x to the 6th. So really when we pull that inside, we're going to represent it as x cubed. And then we're going to have 1 over x cubed, and then that whole thing squared, again, because these x cubed in the denominator here, when we square them, we get x to the 6th. So we're preserving what we're doing. And when we're multiplying by this whole big thing up here, notice that's just really equal to 1. That stuff I have in blue here, 1 over x to the 6th over 1 over x to the 6th, that's just equal to 1. We're just multiplying by 1 in a really, really fancy way. So we're not changing the value of this anymore. And I'm going to rewrite the bottom as 2x squared times x to the 4th plus 3x. And I'm going to break up this x to the 6th right here, where I'm drawing the arrow, into x squared times x to the 4th, right? Because when we multiply two fractions together, we multiply the numerators and the denominators. So really this thing is still over x to the 6th, but I'm writing it again in a nice way so we can get what we want. Alright, so what's that going to be? The limit as x approaches infinity? Well, our x cubes cancel out here, so we'll get 6 plus 1 over x cubed, and that whole thing is still squared, and then we're going to be over 2 times x to the 4th over x to the 4th is just 1. And then we have 3x over x to the 4th. That's going to be 3 over x cubed, right? Because that 1x cancels with one of these 4, and we have 3 left over. Alright, so now we're going to see what happens as x trends towards infinity. So what happens now is this 1 over x cubed is going to trend towards 0. And that's because we're taking 1 and dividing it by an infinitely large number. So if we think of taking 1 and cutting it into infinite little pieces, how big are those pieces going to be? They're going to be 0. They're not going to be very big at all. So that's a way to think of 1 over x to the cubed is going towards 0. Same thing happens with this 3 over x cubed down here. That's going to trend towards 0. Again, we have a number being cut into infinite pieces, right, as x gets really, really large. So that's going to be closer to 0 as well. So then we're left with 6, okay, because the limit as x approaches infinity of 6, and that's going to be 6 squared, because we have the square out here, and that's going to be over 2 times, and then we have a 1 plus 0, so that's just going to be 1, right? And all these constants, the 6 and the 2, we're taking the limit of those as x goes to infinity, but they don't depend on x anymore, so we just get the number. And so that's going to be 36 over 2, and so when we do that, that is going to be equal to 18, and that is our answer. So basically what this tells us is we have a horizontal asymptote, and that's going to be at x is equal to 18. So this function here has a horizontal asymptote at x equals 18. Now in the next video we're going to look at an even more complicated example of a limit at infinity.